This recording is going to be a continuation of our previous recording where we're going to graph a natural log function and then a transformation of a natural log. So first off, it starts out with graph the natural log of x. So we need to get those points. So if you remember, in our previous video, we found the table for e to the x, and then we inverted that table. We changed all the x's to y's and vice versa. So I'm going to be plotting these points, 0.05, comma, -3. etc. So go ahead and plot those points, play the recording when you're ready to proceed. Alright, now I've got a graph of the natural log of x based on taking the inverse of e to the x. And this graph says to make a transformation, g to the x. Well, you should know, based on your experience, what's going on with this. I think we can kind of answer question part C first, right? It says, describe the transformations that have taken place. Well, you know from all your experiences with transformations, if you know the rules, if you know what goes on with a +4 outside the function, +3 inside, we should be able to just do that. So write down what you think are the two transformations, then play the recording. So hopefully you know it's 3 units left and 4 units up. Alright, well I'm going to take each one of those points and go 3 left and 4 up. That graph just continues down, gets really close to this asymptote, but it never touches it. Alright, and the final thing I'm going to have you do here is fill in some information about these graphs, some of the characteristics or details of these graphs. So do as much as you can, and then play the recording when you're interested in checking your answers or getting some help. Okay, so hopefully the domain of this graph. Well, first of all, for f of x, its domain is from 0 to infinity, right? And then the g of x graph, when we shift everything to the left, that shifts its domain 3 to the left. So that's just from 3 to infinity. Next, the range of the graph. Well, they both go from negative infinity up to positive infinity without bound. X-intercept. Well, it's pretty easy for this x-intercept to be identified, right? It's the point where it crosses the x-axis at 1, 0. Tiny bit harder for our other graph to find its x-intercept, but you can estimate it's like -3-ish, about. Well, we can put it into the calculator and find the more precise value by looking at the 0 feature. Alright, we can get that from our calculator, about -3-ish. And the y-intercept, well, there is no y-intercept of our purple graph, right? Never crosses. But this one clearly does have a y-intercept. It's like 1, 2, 3, 4, like right around 5. Turns out it's this value. 5.09, excuse me. Try one more time. 5.0986. And finally, the vertical asymptote. Well, with our parent function, natural log, it gets really close to the line x equals 0, which corresponds to the start of its domain. The green graph gets really close to the line x equals -3, which corresponds to what should be its domain, which I'm now realizing I made a mistake. So let me fix my mistake, which I will do in a second. Alright, I'm going to go back and fix this asymptote, or excuse me, this domain value right here that I did not have correctly. Should be a -3, and hopefully you caught that. Hopefully you were screaming at me through your headset saying, what are you talking about, Mr. Clinton? That's a negative value, not a positive. The bottom part you can try to do on your own. We'll start class with it at some point soon, but you should be able to do those 5 with no calculator. If you do attempt to do them, please don't type them into the calculator. Just use what you know about transformations. Thanks for watching.